Hello, welcome to Demola, and today's lesson we are covering isomerism. So, very interesting topic. We've got two types to discuss today, structural and stereoisomerism. So, no time to waste, let's get straight into it. Okay, so we're starting off with talking about structural isomerism, and literally definitions are king again when it comes to chemistry. So, structural isomers are compounds with the same molecular formula but different structural formula. We've done formulas in our basic concepts video, so go back to that if you need a reminder. There are different types of structural isomerism. I think these ones are probably the bit of a nicer one to get in an exam. So you've got chain isomers where there's different carbon skeletons. So you can see here, and I will just emphasize, being able to interpret and being comfortable with skeletal formula is really important. So you can see here, this one is just pentane, right? So you got 1, 2, 3, 4, 5, it's pentane. The next one here is 2-methyl butane. This one is 2,2-dimethyl propane. So you can see that all of these, literally all of them, if you take a second to look, all of them are going to be C5H12, every single one, right? But you can see they have different structures. Oh, I've written it down. Okay. Positional isomerism. Again, this is when we have with the functional groups in a different place, right? So probably a bit misleading functional group isomerism, but yeah, in a different place. So you can see here, this one we've got 1-chloropentane, 2-chloropentane, 3-chloropentane, going from left to right. So we've got that. And then finally we've got functional group isomerism. This is what I meant. This is one that you have a different functional group. So you can see here, one of them, I will emphasize, this one barely does come up in the A level. Because you don't really need to know what this group is. The other one's an alcohol group. I wouldn't worry about that group. So just know it exists, but it is a bit rarer to come up. So a typical question that they do ask as well with structural isomerism is they'll give you a compound and they'll say draw all the different isomers that you can get. So for example, hexane here. Are you all happy? Well, you should all be happy that we've got hexane, 2-methylpentane, 3-methylpentane, 2,3-dimethylbutane, 2,2-dimethylbutane. So you get a lot of different options into what you can do in order to make these isomers, and you need to be able to work down a list to help yourself to make them. I honestly will say practice makes perfect with this. I typically will go from like longest chain, go down one. So like for example, starting with 6 and going to 5 and going to 4, it wouldn't be possible with 3. So I just kind of do that process, but definitely make sure you do practice this because they do ask this question a lot in the AS. Okay, so we're kind of going to jump forward a tiny bit to do stereoisomerism now. And this is when we have compounds with the same structural formula but a different arrangement in space. Might sound confusing, but I promise you for the exam, definition marks are really easy. Make sure you're saying same structural formula, make sure you're saying different arrangement in space, and then you get your mark for definitions. Okay, so we'll explain what it is. You need 2 factors to be present or 2 conditions for this to be valid, right? You need restricted rotation across a carbon-to-carbon double bond. I need 2 different groups to be attached to each carbon. So what do you mean? I'll look at this example here. I'm saying that this is a carbon in a double bond. That's another carbon in a double bond. It needs different groups attached to it. So here we have a hydrogen and a methyl, right? That's what we mean by different groups attached to the carbon in the double bond. So we need that to be present and we need the double bond. Yep. And then you'll just say in exam that there's restricted movement across it. So the first type we need to talk about is EZ. This is a type of stereoisomerism. And if you know German, this will be really useful. Entgegen is opposite. Zusammen is together. I didn't do German, so if I mess up the pronunciation, please do not slaughter me in the comments. Okay. So this again, you look at your bigger group, right? Here, hydrogen is always going to be lowest priority pretty much any time. And we'll talk about priority in a second. So identify which group is high priority, right? Are they on the same side or are they on the opposite side? If they're on the same side, we're working with a Z isomer. You can see here, if they're on opposite sides, E isomer. So you identify the high priority group and then you say, are they on the same side? Are they on opposite side? That gives you your answer. Yeah. I just wanted to show you this as well. So you can see here, we've got our carbon, but it's attached to the same. So because these are the same, this one does not have stereoisomerism. So that is a very important thing that you need to know. But all of these are butene. Yeah, this is but1ene in red. Another one's are stereoisomers of butene. Okay. Now we need to talk about cis-trans isomerism, right? And we are using the same example, but cis-trans is a special case of EZ where there's an identical pair across the double bond. And what I mean by an identical pair again across double bond is that you can see we've got a pair of CH3 and we've got a pair of hydrogens. Yeah? Does that make sense? So you can see we've got pairs across double bond. It doesn't really work well when we're dealing with the Z isomer, does it? But you can see we've got pairs across the double bond, and that's going to tell us we can use cis trans. Now, cis, I remember, so cisgender means someone who's the same gender as they were born as their biological sex. So this is going to be cis here, and then this one, opposite, trans gender, when somebody is changed, they've changed from their biological sex. So this is now trans. So that's kind of what I used to remember it. So cis and trans. Now, you have your Cahn Ingold Prelog rules, which is essentially what determines the priority. And literally, for your A levels, I think some people kind of go really complicated with this and they confuse themselves. Just remember, a higher atomic number has higher priority, and you have to work down the chain until you get a difference, right? So here, we're thinking you have to look at the carbon in a double bond, and you need to see what is immediately attached to it. So we're comparing carbon and carbon here to hydrogen and hydrogen. So when we look on the one side, let's look on the left first. Which has the higher atomic number between carbon and hydrogen? Well, it's carbon. Carbon is 6, hydrogen is 1, right? Same here, 6 and 1. So we're saying that the carbons have the higher priority, meaning that this is a Z isomer. Yeah? Same thing here, option B. This is 1, this is, I believe, 9 off the top of my head. This, I believe, is 17, and this is 6. So we're saying that's higher priority, because we're looking on different sides. So now it must be E. Yeah? And finally here as well, we've got 17, 9, 9, and 1. So we look high priority. So this is a Z isomer. I hope that all makes sense. So just look at the atomic number and go from there. If you had a chain, so for example, I'll just quickly write this in. If we had a chain, so say we're comparing CH3 to ClH2, we look at the first point of difference. So we've both got a carbon, fine. The first point of difference comes through the hydrogen and the chlorine. And this is 1, this is 17. So this group at the bottom is the higher priority. I hope that makes sense. Okay, very short one, I hope. So here are just some questions just for you to give a go, just to test yourself. You've got 3 different questions there. Give them a go, pause the video, then we'll come back with the answers. Okay, it's answer time. So C6H12, I would have immediately thought of an alkene, but the question specifically asks for an alkane. So the only way to get that is if it's a cyclic compound. So that's why they've gone cyclohexane now. And then now they're asking for, what are they saying? They said branch chained isomers of B, so B is actually hexane. So in terms of branch chained isomers, again, we're working down. So start with pentane. You can have, for example, here, I'll just highlight them as we go. So you can have 2-methyl pentane, right? You can have 3-methyl pentane. When you've done that, you've exhausted all your options with pentane, right? So now let's go down to butane. You can have 2,2-dimethyl butane. You can have 2,3-dimethyl butane. So you can see that you just work down from your longest chain and try to get different solutions there. If you try to go through, you would realize you cannot do it. So, and then also structural isomerism. Now the next one is explaining why EZ isomerism happens. We've went through this. Remember, you're saying no or limited, restricted rotation across the carbon-to-carbon double bond. And also you would have seen that there's 2 different groups, 2 different atoms or groups of atoms that's attached to the carbon that's in the double bond. So make sure that you're being very specific with your wording there. Now the next one, you have to draw out this molecule. So they give you the molecular formula, I believe it is, yeah. So they give you the molecular formula here. And they've said it's chloroethene. So you know there's a carbon-to-carbon double bond in here, yeah? So I would immediately start with that. We've got 2 carbons, draw it out like that, like so, and then just fill in the rest of the molecule. So we've got the 3 hydrogens and the chlorine. And then I think going from displayed to skeletal is a lot easier for me. So that's what I typically do. So you can see that's the answer that you would have got up here. And then finally, why can't it have EZ isomerism? Well, you can see what was our requirements. We look at the carbons and the double bonds. We're looking at these 2. They need to have different groups attached. Here, yes, chlorine and hydrogen are different. But here, hydrogen, hydrogen. So we are not going to have EZ isomerism. I hope that all makes sense in terms of explaining those answers. Okay, definitely a bit of a shorter topic, but one that is very useful to know. In terms of what you want to be doing, what you not want to be doing in this topic, definitely naming compounds is going to be a massive strength for this topic. It just will be. Understanding the requirements for EZ and cis trans as well, very, very good in terms of your not really the Cahn Ingold Prelog rules, more about like the restriction of the rotation, and then also having different groups of atoms on the each of the carbons in the double bond. Yeah, and then just knowing the different situations where isomerism can occur. So this is, I'm more talking about structural isomerism in terms of like your chain isomers, your positional ones, your functional group ones. I know I did mess it up at the start of the video, but yeah. In terms of what not to do, I think a lot of people overcomplicate the Cahn Ingold Prelog rules. I think you literally just need to kind of focus on higher atomic numbers, higher priority. If it's the same that's attached to the carbon, they just kind of work along the chain until you find a difference. I think that's really what you need to kind of focus on for A level. And then the different potential structural isomers, like we did with the hexane in this video, you need to just be able to kind of send that actually with any compound that they give you. So very, very useful to know that how to do that. And I think you can just practice it really. And then skeletal formula just becomes really important all throughout your chemistry course. So I would, especially now that you've just started organic chemistry, I would be very, very focused on making sure that you can do skeletal formula well. So I hope that all makes sense, and I hope that's been very, very useful in terms of learning what is isomerism, how do you apply it. If you liked the video, please drop a like on the video if you enjoyed it and you found it useful. Also, any questions at all, drop a comment below. I'll do my best to answer in good time. We've also got and please subscribe to the channel. So we are closing in hopefully on 1K subscribers soon. So that would be a really, really massive milestone. So thank you to all who have subscribed, and if you can, please do. I really, really appreciate it. We've got Instagram and our TikTok, both at ASL Demola. Links will be in the description below. But that's all from me for now. Thank you so much for listening. Hope it helped, and I'll see you in the next one. Bye for now.